So if we reflect on what just happened, and again, this was based on a real bug using a transliteration into Ruby of real code that caused a real problem for a real company. One of the things that we did in that is what I call glass box testing. Some people also call it white box testing. That's a kind of testing where you're writing tests for a method with knowledge of how the method works, right? So when you're doing things like calculating leap years, you know that there are certain values where the function will behave differently, right? What we call them critical values. And then there's non-critical regions. So a leap year that meets all of the conditions is a critical value. A leap year that only meets some of the conditions, like it is a centenary year but not a 400 year, that's a critical value. But for the non-critical values, sort of any value would work, right? So a common approach when you're doing unit testing is try to identify the critical values, which means you do know something about the implementation of the method, and then pick a representative one from the non-critical value ranges. And that's the strategy that, in this case, helped identify that bug. We also saw, and this is a little bit counterintuitive, so follow me here, refactoring reduces complexity. If you ran some of the metrics, like the assignment branch conditional score that Flog computes, the original method we started from has a score of 23, which is pretty high. In the new version, each individual method, like all the helpers, have scores of 12 or less, which is much better. So the number of lines of code actually went up, but the complexity and the readability and the testability all got better. And this is sort of a non-obvious thing about refactoring. Sometimes refactoring lets you find a shorter way to do things, like do it with less lines of code. But there are occasions where refactoring will increase the total quantity of code, but it will be divided out in a way that makes the metrics better and makes testability better. And that, at the end of the day, that's really the goal. Having less code is not always good, right? But having more readable, less complex code, that almost always is good. There's a lot of other code smells you might look at. The ones that we used in this simple example were we decomposed a conditional, meaning we had a conditional that had multiple clauses and it had nesting, and we reduced it so that any individual conditional in our final version was just a simple one-level conditional with a single clause. We did a lot of extracting of methods. So taking a chunk of work that is inlined into a function, trying to encapsulate it, moving it into its own function, and then being able to separately create tests for that. And we also extracted a class. We found that the year and day arguments seem to sort of be touched by multiple helper functions. And when that happens, that's sort of a cue that you should say, oh, maybe there's a class to be extracted here. And then all of the instance methods within that class will automatically have access to those instance variables and to those attributes. So what are the goals of method level refactoring if we sort of take a step back? Is it to eliminate code smells? Absolutely. Code smells get in the way of programmers understanding the intention of your code, and that makes it harder for them to modify. Improving testability? I would think so. Imagine some of the things that we were testing when we tested our helper methods. It would have been very awkward at best to try to test those behaviors when they were still sort of buried inside that top-level function. Eliminating bugs? That's not really a goal of refactoring, but as we saw, sometimes the process of reducing complexity through a refactoring can make it easier to find bugs that otherwise might have had a place to hide. So eliminating bugs is not a goal, but sometimes it is a happy side effect. Certainly reducing the complexity of the code, but that doesn't necessarily mean reducing the size of the code. Sometimes more code with less complexity is a better outcome. If you're refactoring, will existing tests fail? Almost certainly, at some point during your refactoring, existing tests will fail because tests that are unit level are often making assumptions about the implementations of methods. That's why we call it glass box testing. And if you're changing the implementation of the method by pulling stuff out of it, it is entirely possible that for a short time, some of those existing tests will fail. So that just means that as you go, as soon as you make a little change, make sure you understand which tests are failing and why, and make the necessary changes to get those tests to pass again. So refactoring doesn't mean that at all times your tests will pass, but it does mean that by the end of your process, they're all passing again, and you understood why it was you had to change them. So yes, refactoring will usually result in some updates, especially to unit or module level tests in your test suite. And that's why we do refactoring, ladies and gentlemen.